Hello, in the last video we went over the geometric definition of the dot product, but now we're going to go over the algebraic definition of the dot product. And if you are given two vectors u with components u1, u2, and vector v with components v1 and v2, then u dot v is just simply u1 times v1 plus u2 times v2. So you take the corresponding components, you multiply them, and you add them together. So real simple. So, but now we're going to supply a proof to show you how that works out. So imagine that we have, let's say this is the x and y axis, and then let's say that this vector right here, that's going to be vector u, right? And then if we have vector v going that way, right? Then we can, and we'll call this angle right here, we're going to call this angle right here alpha, and we're going to call this angle right here, so that one's alpha and that one's beta, right? Good. And then the angle between it, if we call that one theta, right, that's going to be beta minus alpha. And then I can take, if I take the cosine of beta minus alpha, using the subtraction, the compound identity for this, this would be cosine beta cosine alpha plus sine beta sine alpha. Good. Now let's see what these are equal to. Now coming back to this guy right here for vector u, right, we know these components, this would be u sub 1 and this would be u sub 2, right? That's how far it goes over on the x, and this is how far it goes up in the y, and vice versa for the v, right? There's a right triangle here. This would be v sub 1 and this would be v sub 2. So let's start with this one. For angle alpha, this right triangle, I know that the sine of alpha would be u sub 2 over this length, which is magnitude u. So it would be u sub 2 over magnitude of vector u, right? Then the cosine of alpha would be equal to, I'm going to write it down right here. I'll write it. So the cosine of alpha, right, would be u sub 1 over magnitude u, right? And the same thing we could do for beta, right? I could say the sine of beta, right, is going to be v sub 2 over this length, which is magnitude v, and then the cosine of beta would be v sub 1, this length, over this length, so v sub 1 over magnitude v, right? And now I can go ahead and do some substitution over here. I can do some substitution and say, well, what's the cosine of beta equal to? That's v sub 1 over magnitude v. What's the cosine of alpha? Times u sub 2 magnitude u, plus the sine of beta is v sub 2 magnitude v, right? The sine of alpha is u sub 2 times magnitude u, right? Good. And we know this side here is beta minus alpha. We can write that as the cosine of theta, which theta ends up being the angle between these two vectors, right? And if you notice here, in the denominators, I have magnitude u, magnitude v, magnitude v. I can multiply both sides by magnitude v, so I have magnitude u times magnitude v, cosine theta is equal to u sub, well, this should be u sub 1, right? This should be u sub 1. And then so this would be u sub 1 times v sub 1 plus u sub 2 times v sub 2, right? And I've almost done here, but this is the geometric form of the dot product. We know this to be u dot v from our past video, right? And then that is equal to u sub 1 times v sub 1 plus u sub 2 times v sub 2. And there you go. This is the geometric form, the algebraic definition of the dot product. So there are two formulas for the dot product. And real quick, in 3 dimensions, it turns out to be the same thing. If you have a vector u with components u sub 1, u sub 2, u sub 3, and vectors b in 3 dimensions with components v sub 1, v sub 2, v sub 3, then we know that u dot v in 3 dimensions will be u sub 1 times v sub 1 plus u sub 2 times v sub 2 plus u sub 3 times v sub 3. So dot product works in both 2D and this is 3D. Sound good? So thanks guys.